Okay, so we were on number 3 from the sheet. It's telling us the muzzle velocity of a cannon has an upward component of 490. So if we separate out our x and our y, so our VIY is 490 meters per second, and our VIX, it's telling us the horizontal component is 600 meters per second. So rather than me giving you the VI and the theta, I gave you the components. And it wants to know how far upward will it shoot and how far will it go. So of course AX is 0. We don't know the time and we don't know the delta dx, but we want it. In the y direction, AY is 9.81 meters per second squared. This guy's up, A is down. We want to know the time and we want to know delta dy max. So it's identical to the other ones. Your first step, do AY is equal to VFY minus VIY over delta T. Look at just the up. The VF goes to 0. This becomes TU. So TU is equal to negative VIY over AY. This time we don't have to do VI sine theta because we have 490 meters per second. It's a negative, and A is also a negative, 9.81 meters per second squared. Where did my calculator go? There it is, because I don't trust my answers. So 490 divided by 9.81. Whoops. I missed the 9. And just divided by the 8.1. 49.949 seconds, which means the full time is 99.898 seconds. Okay, it doesn't ask us for either of those, but we need both of them. Part A wants to know how far up will it go. It's looking for delta dy max is equal to VIY delta t plus 1/2 AY delta t squared. So delta dy max is equal to 490 meters per second times the 49.949 seconds plus 1/2 negative 9.81 meters per second squared times the 49.949 seconds squared. Again, one term should be twice the other. So times 490. The first term is a huge 24475 meters, 0.0 stuff, minus brackets 4.905 times the time squared, close the brackets, 1,22375 with decimals, and lo and behold, you get 1,22375 point. Oh, the point's in front of the 5 actually. 0.5 meters. Okay, it was in front of the 5 there too. I just didn't notice. And then part B, delta dx. So VIX delta t, 1/2 AX delta t squared. Again, this is 0. So delta dx is 600 meters per second, and this time times 99.898 seconds. Delta dx equals times 555,938.8372. I'm kind of scared to look at what answers I gave you there. Oh, that one's better. I don't have any idea what happened in those first couple. All right, number 4 says a baseball player throws a ball straight into the air at an angle of 30 degrees with the ground. So not really straight into the air. Okay, so this away. VI, an angle of 30 degrees with the ground, with the speed of 50 meters per second. How far from the player will the ball land? Looking for delta dx. Okay, but to find delta dx, you need to find the time in the air, and to find the time in the air, you're going to need to do AY is equal to VFY minus VIY over delta T. If we look at just up, this will be TU, this will go to 0, so TU will equal negative VI sine theta, because that's what VIY is, over AY. So TU will equal, I know I didn't write my stuff down, so VIY is equal to VI sine theta, AY is equal to 9.81 meters per second squared, down, and then X, VIX, VI cos theta, AX 0, and we're trying to solve for delta dx. All right, so negative 50 meters per second sine of 30, so that should make the top 25. 25 divided by 9.81 meters per second squared is 2.5484 seconds. You got to double that because that's just the time up. So 5.0964 seconds. Take this time up, go over here, delta dx is equal to VIX delta t, 1/2 AX delta t squared, but this term goes to 0. So delta dx is equal to 50 meters per second cos of 30, and that gets times by your 5.09689, etc. seconds. So times 50 times cos 220.6996 meters. Okay? And the last one, number 5, says a projectile hits the ground 10 seconds after it was fired. So it's telling us the total time. X VIX is equal to VI cos theta. AX is equal to 0. Delta T is equal to 10 seconds. Y, VIY is equal to VI sine theta up. AY, 9.81 meters per second squared down, and the full time 10 seconds, so the time up 5 seconds. And it wants to know, it moves a horizontal distance of 600 meters, delta dx is 600 meters. And it wants to know what was the original velocity of the projectile. So we can find the VIX, right? So we know delta dx is equal to VIX delta t plus 1/2 AX delta t squared, and this is going to 0. So don't break your VIX down into VI cos theta, just leave it as VIX, delta dx over delta t, so 600 meters over 10 seconds, and so your VIX is 60 meters per second. And then we can get our VIY using our time up. So AY is equal to VFY minus, AY is equal to VFY minus VIY over delta T. And if we're looking at up, this goes to 0. So negative AY delta TU. So VIY is equal to negative 9.81 meters per second squared times 5 seconds. VIY is equal to 49 times 5, 49.05, I did know that, seconds, and it's positive, so that's up. Once you have those two, then you can just do Pythagorean theorem. 60 meters per second, 49.05 meters per second, square them, add them together, take the square root, find the angle. So, I don't know what I just did. 49.05, going to run out of time, plus 60 squared, take the square root, 77. VI is equal to 77.498 meters per second, and then the angle, flip, times 60, second function, 39.266 6 degrees.